Hey, what's up? Welcome everyone. It's Andrew here doing the live stream today. We've got some fun stuff going on. Going to kick off the stream doing some Q&A like we usually do. And then I'm going to be doing something a little bit slightly different from what Alex does. We'll be taking a look at some reverse engineering, binary exploitation, assembly stuff today, and walking through a challenge that I actually wrote myself to teach about buffer overflows and intro to binary exploitation. But we'll kick things off here with some Q&A. So if anyone's got any questions about anything cybersecurity, job hunting, binary exploitation, hardware hacking, IoT hacking, whatever you want to ask, hit me up, and I will try my best to answer them. So give a shout out to a few people here. So John Rogers, hey, definitely in here first. So nice being first in chat. How's everyone doing today? See a bunch of people saying hi in chat. So nice to see some friendly faces and some hackers showing up here. We've also got a few upcoming things that I wanted to give a quick announcement about. We've got our PNPT live training that is coming up soon. So this is a PNPT accelerated to help you get prepped for taking our PNPT exam. We don't offer these too often, just when we have availability to do so. So if you are interested, definitely take note of that. We've also got a couple other live trainings come up. So we've got an Active Directory live training, our popular hacking and defending Active Directory. And then we've also got a blue team coming in as well. All right. So first question here. This is maybe one that would be better for Alex, but I think I can take a shot at answering this. Is there any way to perform SQL injection without using the login screen on a web app? The answer to that is yes, definitely, 100%. So, I mean, there's lots of other places that's potentially maybe passed in to SQL database, not just login screen. There's lots of other parameters. And then if you're more specifically asking, like, do you have to actually visit the login screen yourself? No, the answer to that is no. You can definitely use something like Burp Suite or even curl or other automated tools so that you're not having to manually copy and paste your payloads or your injections right into the login portal of this. Okay, this is a good question here. Glad to hear you're doing well. You're just starting your cybersecurity journey. Is there a suggestion while you're doing school of where you should be applying? I don't have any certs yet. So I think an excellent starting spot here is definitely the help desk. If you're wanting to get into cybersecurity but don't have any certs yet, I would start looking for entry-level help desk positions. If you're in school, sometimes, like I remember at my university, there was help desk positions in the university part-time for students. So I would definitely recommend checking that avenue, see if your school does. Just had a suggestion from someone actually working at TCM that a good place to look is like local or state level governments. If you're not in the US, then maybe like province or something like that at that level, because they're frequently looking for positions and it can be a good way to find an in and get your first job. The other thing I always suggest too, because you're mentioning here that you do not have any certs just yet, is I would suggest also going and looking at job postings of like, what's your dream job or your dream starting job, and seeing what certs they have in the required field or suggested, and then gearing your study and the certs you plan to take towards that, because we don't want to be wasting our time or money on certs that aren't going to help you get the jobs that you want. All righty. Okay, when can we expect the PHDA? So for those of you not familiar with this acronym, that is the Practical Help Desk Associate, which is going to be the newest and next certification coming out for TCM Security that accompanies our Help Desk course, which if you haven't checked that out, it is 100% free in the TCM Security Academy. And the plan for that course is, or for that certification is, I can't give a specific date, but we are in the range of most likely days or weeks, probably in the days till it comes out. So very, very soon, just getting a few last things ready. But I am really excited for this one to come out because I don't think there are any exams like this right now on the market at all. Okay, you got your PJPT. So first thing, congrats on getting your PJPT. That's a TCM certification we offer here, the Practical Junior Pen Tester. You have to apply for internships as a software engineering student this summer, and you want to know how to pick companies to apply. What sort of things should you expect? Any advice would be appreciated. So there's a couple things that I usually look for when I'm applying. For internships, sometimes they can be competitive to get into. So you may want to take the approach of applying to as many as you can find that you think you meet at least 50% of the criteria for. And then, if you get a bunch of interviews and offers, you can pick and choose your best from that. I think the other thing to take a look at is if you can find anyone that you know in your network or reviews on Glassdoor or something like that, see what people are saying about the company. And then for what you should expect, I would actually really recommend taking the TCM Security Soft Skills course, which is also free. So you can check out and make sure that you're ready for interviews and what to expect. They're probably going to ask you like very basic, tell me about yourself questions, maybe like, where are some places you worked? Have you ever dealt with conflict at the workplace? They're probably going to be more looking for those type of questions at a entry level internship than like deep technical things, because they just want to make sure you're going to fit in with the people that you're working with, and that it's not going to be a bad time for your coworkers. So I would make sure to check that out, and do some mock interviews if you can, even with yourself in front of the mirror. I always recommend doing that. What should I be doing next? One, get a master's in cybersecurity, or two, some certificates. So this is a tough one to answer because, again, I mean, there's no path for everyone and it's going to differ. But this is similar to the other person's question, where when people ask me these, I always say, like, find what's your dream job, or like your dream job in 5 years or your next dream job. And then from there, go and look at what those are asking for. Are they asking for a master's or a bachelor's in cybersecurity? I'm honestly not seeing as much of that myself, at least in my area in North America. Are they looking for certificates? If they are, like, what certs are at the top of that list? Because realistically, like, certifications, they have two purposes. One of them is to prove to someone who's non-technical, but that's going to be screening them, that your stuff. So they'll have a list of ones that they know, if people have passed this cert, they probably know their stuff, as long as they didn't cheat on it or something. The second purpose is that it forces you to study and learn yourself. So if certifications aren't meeting one of those two requirements, they're probably not worth doing. And if you're just looking for it to land a job, then you should just go look at the exact jobs you want and see what certs they need, and then try and land those certs. So that's my opinion on that one. Here's a good one. How to start with IoT pen testing if you are just beginning with pen testing. So, to be honest, I actually would recommend not doing IoT pen testing if you are just beginning with pen testing, because it is a little bit more complex and complicated of a subject. And I think you will be a lot better off starting with the basics. So something like the practical ethical hacking course, or if you're not using our resources, just starting out with more basic, either network or web. Get all that stuff out of the way. Make sure you understand, like, what's an exploit, what's how networking works. the basic things like what's command injection, what's remote code execution, what's a buffer overflow. Try and get all that stuff out of the way, and then get started with IoT pen testing. And if you're looking for free resources, we've got a few on our YouTube channel. We've also got a really good blog that's whole free series, 4 parts long, like a lot of detailed training, walking you through how to get started in IoT pen testing. So I would go there. I mean, you can just Google um, TCM Security IoT hacking blog, or maybe Britt can drop it in the chat. But it's a really good resource. Walks you through everything, what you need to buy. Yeah, Britt just dropped it in. How to buy stuff for cheap and not waste your money. All that good stuff. I would suggest starting there. Okay, binary exploitation cert. Not something currently on the roadmap, but like personally, something that I'm very interested in. So I would absolutely love if we were to be able to do one. It's definitely something I am interested in. So I will say that much, and maybe um, try and push in the background for me to be able to create one, and also another assembly course as well. I'd like to do an assembly one that's more focused not on the basics and fundamentals, but binary exploitation, fuzzing, spiking, probably some Windows stuff as well. So if anyone hasn't taken it or doesn't know, I have a assembly course out on TCM Security. It's Assembly 101. So focus on the fundamentals and basics of that. Okay, I am in 11th standard, so I don't know if that's maybe a grade, but you started doing bug bounties, so great job. Honestly, sometimes getting started with things is just the hardest thing. So, what should you do for success? Love from India. So, perfect. Thanks. I know we have a lot of people from India stopping by our stream, so appreciate you all coming by. So I'm not a big bug bounty person actually myself, just because personally I don't find it to be worthwhile of my time at least, but it can be an excellent learning experience. So the two tips that I would give is either one, um, pick something that you know and get really good at it and look for that. So whether and I wouldn't pick like XSS or something that's really common, but try and pick something that's a little bit less common, and then see if you can get really really good at doing that. If your goal is to like actually just find bugs. And then the other thing that I always suggest is try and do things or stuff that you're interested in, and it will be learning for you, even if you don't find bugs and get paid, because then it kind of makes it worth your time. Whereas if you're just starting out and you're just trying to only do it to get paid, then I feel like you're not going to get your values worth out of your time. But if you're going in with like the expectation that I'm going to try and be learning or doing something that I enjoy, and then if I do find some and get paid, that is a bonus, then I think that's a much better strategy. How to learn SCADA pen testing. So there is actually honestly not a lot of good resources out there that are affordable for SCADA. So for people that aren't familiar with this, this is supervisory control and data acquisition. So this is like IoT ICS pen testing. And a lot of the resources for this have been very expensive because it is kind of a tricky thing to teach, because these kind of systems are very expensive, like only in industrial systems. So if you want to get your hands on one to learn how to do it, it's quite expensive. I do know of one content creator that is making affordable SCADA OT ICS, and he has a Udemy course. I believe it's actually called like practical uh, OT hacking or something like that. But if you look at for it on Udemy, you can find some of them. He goes by Marcel Rixen, and he has some YouTube content. So if you're looking for something affordable, I would start there. The other good place to look is if you check out Dragos, as a company that does a lot of this kind of pen testing. Their founder, Rob Lee, he has a blog about how to get started on this stuff and like what you need to learn. And a lot of it is like the basics of how like engineering fundamentals work, control systems work, because A lot of SCADA and OT and ICS security is not as much pen testing with exploits like we would in other ones. It's more auditing because these systems are very fragile and it's very easy to break them or accidentally take them offline. You need a lot of experience before getting into the pen testing field. Yes, and no to this. I will say right now it is difficult to land your first pen testing job. Like that's just the reality of the job market. And it seems like everyone wants to also get into pen testing. Like it is the cool red team is the cool side of security. When people are first learning about security, that's what they're interested in. And I'll say like that was me as well. Um, and I would say it's probably like a 10-to-1 ratio of blue team jobs to red team jobs. And if you're coming into cybersecurity without any security experience and then looking to go straight into pen testing, you're going to be up against a lot of people. And there's probably quite a few of them that will have had blue team experience, and they will definitely get preferential treatment for that from things like recruiters, hiring managers, whatnot. It's not to say you definitely have to go that path, but it's definitely going to be harder if you don't have any IT or blue team experience. So something that I've been recommending to people that reach out to me now is like, would they consider trying blue team first and then, mapping out a path for success that they want? I'm going to do blue team for X amount of years, then move into pen testing. Not to say that you have to do that, and everyone's path is different, but in my opinion, that is a much easier way. So I'll take a couple more questions here before we actually hop into reverse engineering. Okay, I have a couple here that are good. So, okay, good resources for reverse engineering from zero to hero for Windows, not Linux. Okay, so I would start with actually learning assembly first. So you don't have to be like a pro at assembly, but I think you definitely need to understand the basics of assembly. And honestly, whether you start that on Windows or Linux is not really going to matter. And whether you start that for ARM, x64, or x86, whatever architecture, the basics of it are all the same. Like, do you understand what the registers are, moving into registers? How does conditional logic and comparisons work in assembly? How do jumps work? Nothing specific to any language itself or operating system. And then from there, I would actually move on and make sure I have a solid understanding of C. It's going to be really important for reverse engineering nowadays because most likely you're going to be using disassemblers like Kedra or IDAPRO or Binary Ninja that can actually not only just disassemble into assembly, but can also put that back into a C representation. So you need to be able to understand, at least read C, and have a good understanding of memory management. And then once you got those down, I would start then trying to learn actual reverse engineering itself. So you kind of almost need to learn forward engineering first, if that makes sense, unless you're there or not. And then from there, go to reverse. And one really good resource that I use for learning reverse engineering is TryHackme, which there's a bunch of them that have walkthroughs and challenges starting from fairly easy all the way up to fairly complex to learn about it. So I would go there next after that. Okay, do you have courses for basic networking? So we are working on one that's going to go out on our free tier for networking. Uh, and then we will, have a full one. For the time being, right now, the two resources for basic networking that we have is inside of the help desk course. There is a couple of hours worth of training for networking itself. It is fairly basic. We do go over like networking troubleshooting, OSI layers, um, you know, three-way handshake, what's the difference between TCP and UDP, all of that stuff, setting up a basic Wi-Fi router, what are switches, what are routers, what's the difference between them. But we don't get into like, subnetting or setting up like a small network, business network or anything. But we do have a more advanced one that will be coming out on the free tier soon. So those are the good free resources we have. So what I'm going to do now, since I've been chatting for a little bit, is I'm going to hop over to my virtual machine here, and we'll get started walking through this challenge here. Let's get rid of this chat here too. All right, perfect. So I am going to be walking through Overflow Me, which is actually a challenge that I wrote to teach about the basics of assembly and reading assembly and getting into reverse engineering. So if you want to follow along with this, I'll get Britt to drop it into the chat right now, but it's just on GitHub here. So I'll pop it open here. This is it right here. It's on my GitHub profile. Yeah, Britt says she already shared it, so maybe we'll drop it in here again. So just quickly looking through here. This is a walkthrough for learning the basics of binary exploitation, and there's actually different levels right now. So far, I've just released level 1, but I'm hoping to put level 2 out soon. So the nice thing about this is each challenge includes detailed instructions, stack diagrams, fully commented assembly, source code, and there's multiple levels in here. So I'm not going to be showing this part today, but if you'll need to install a few tools here. So you'll need GCC, GDB, XXD, Make, and Git. And then other than that, you should have everything ready to go. So the first thing to do is actually just clone the repo here. So I'll just grab it actually from here. And then we'll walk through this whole thing together here today, show how to do this. And if you're following along and have any questions, or you're just following along, let me know. I love to hear if people are following along. Let's bring up the terminal here. Alrighty. So we'll just clone this in here. Perfect. And then I'll open it up in here. Personally, I like using VS Code when I'm doing this kind of stuff, especially when I'm reviewing source code itself, because I just find it a lot easier to just have it all in one pane of glass. But you could definitely do this from just a terminal as well if you prefer. Perfect. So I see someone, this is so on my death, but I am following along. So I would say like it, honestly, this is like the first level of this. And like, I think that most people probably follow along with this. So, I mean, don't be discouraged. Vim hater also. Do you hate Vim or do I hate Vim? I actually really like Vim, but sometimes it's not the best for like streaming and learning and stuff. All right, so let's open up the README here. So inside of each of these, now there is a folders, and they have their own README, which walks through everything, which is kind of nice. So actually just going to open up this one here, and we take a look at the challenge. So the very first thing or challenge we get here is your challenge, should you accept it, is to get the Overflow Me binary to print out the hidden message, hey, you're not supposed to be here, without modifying the source code. So if you want to follow along, all of the instructions are in here. So if you actually go pack over, I'll just hop over and quickly show this here. So if you go inside and like actually render these README files, then you can actually see all of the source code, everything you need to copy, including pictures and everything. So Might be nicer if you're actually wanting to follow along with this to take a look at it in the browser instead, or you can get extensions in VS Code to render markdown files. So I'll just be using this one. So the very first thing we need to do is assemble and link the binary. So I used make files inside of this just to make our lives a lot easier. So the first thing we'll do is just build this. And to do that, I'm just going to copy and paste these commands in here, or maybe I'll type some of them, but we'll build this here. Got to change into the directory first here. Perfect. So now if we list this out, we should have that file. We got that binary. So we can actually give this a spin now and just run it. And you'll notice it asks us here, my buffer is open for input. Please don't overflow me. So what I'm going to do is I'll just give it a quick test and say, hey, this is Andrew on the stream. And we'll hit here. So perfect. So all this binary does is very basic. It just echoes back what you print in. And then in our example here, it says, thanks for not overflowing me. So it's definitely asking for us to overflow it. So the next step in this one, since this is designed to teach more about what happens in the background with buffer overflows, is we're going to take a look at this from the inside, and we're going to take a look at the source code. So not disassembling or really reverse engineering at this point. We'll just be reading that. So it is compiled from this assembly file right here, which most of this actually comes from C code that I wrote, and then I assembled that into assembly. However, I did make it just a few small changes to it just so it's a little bit more readable for people that are taking a look at this for the first time and not used to taking a look at assembly. So usually the first thing I'll do is I'll actually jump down to main, because that's actually going to be the entry point for code that started as C. So if we take a look down, we've got some functions here, but if we come down here, we've got our main section. And then the nice thing about doing it this way without reverse engineering is I have added comments about what basically every single line of assembly code here does. So for example, here we are in the code to print the intro message, and all of this code here is setting up to make a syscall, which a syscall is when we pass over to the operating system to do something for us. And in this example, it's going to just be to write to standard out. So we set up the registers inside of the processor so that when the syscall gets called, it knows what we're asking it to do. And to do that, we need to set the REX register to 1. We set the file descriptor to point to standard out. We send in a pointer to the intro message, and we say how long that is. So this is what then prints this. My buffer is open for inputs. Don't overflow me. We then call a function, which is called echo print. And then after we return from that function, we print the outro message, which is that thanks for not overflowing me. So if we don't overflow it, so what we need to do now is follow our jump here of this call to go into echo print. So what I'll do is come up to echo print here. And inside of echo print, we have what's called the function prologue at the top. So what that is doing is it's actually setting us up, setting our stack up in a way that it's going to allow the function to operate properly and also not mess up the stack for the caller. So after the prologue here, you'll notice that we're allocating stack onto the buffer to hold the input string. So when we actually ask the user for the input, what we're going to be doing is storing that input as a temporary variable on the stack. And you'll notice here we are storing 512 bytes for that. We then have the code that actually reads it into the stack. And we're doing a syscall for that. And you'll notice that we have a read syscall now instead of write. So we're just writing in from standard in. And we have our file director set to standard in. So after that, when we set up for this syscall, we have a pointer to where we're going to store the data that we get from the keyboard input. So you'll notice what we're doing, and this is how this would work like in C compiled code, is since this variable that we've created, or this essentially like creating a variable that has scope only inside this function, that means it's going to be temporarily created and it will live most likely on the stack. And what we've done here then is we've pointed and said, hey, we allocated this space onto the stack, so minus 512 off of the base pointer. And then here we are saying how much we'll read in from the read syscall. So the read syscall already has protections in place to prevent something like Stack Overflow coming in, but it's up to the writer of the code to make sure the amounts that they allow to come in is not going to exceed the size. So right here, this is actually, when we see this, this is the hint to us that yes, we're going to be able to have some sort of overflow take place here, because the user can input more into the buffer we've created than we have space for. So what we could do is we could just run this again and, go in here, go overflow me, and then we could try and like do a keyboard walk, but we'll need to actually get over 512 characters in order to do that. So one thing that I like to do when I'm doing buffer overflows, binary exploitation, is to actually use a Python script. So I've got one created that we're going to be using here, and you can run with as well. So it's called exploit.py. And right now what we're going to be doing is we're actually just going to be filling all of this up with A's. So X41 in ASCII, that's A. So we'll just fill this whole thing up with A, and then we're going to come back and talk about what this return address is later. So for the time being, we'll just actually fill this all with a bunch of A's and then see what happens. So to do that, we can actually just run this. So we can go Python 3 exploits.py. And you notice if we run this, we just get a bunch of A's printed out to the screen. So if you've ever done any type of buffer overflow or binary exploitation, the first one you do, you always put A's into the buffer. Just need a question. Is this pre-recorded or live? This is live. I'm doing this live, so you might see some mistakes, but I am doing this live. So, oops. So let's clear this out of the way here so that you guys can see everything, because we don't have a new line, so messed everything up. Okay, so what we can do is we can actually pass this into the binary, so we can pipe it in. So we'll go Python 3, and we'll pipe this into /overflowme. And then you'll notice that it pauses for a bit, and then we get segmentation fault core dumped. So we actually now have crashed this. So what we're going to do now is go into GDB, which is the GNU debugger, and we'll walk through why this is actually crashing and then see if we can't solve the challenge. So to do that, I'll clear this out here again, and we'll go. First, what we're going to do actually is I'm going to make a file, because it's a lot easier in GDB instead of trying to pipe to take the input from a file. So we'll exploit.py, and then we'll pass this in. I'm just going to call mine AAA. Here, make sure it's all good. Perfect. So to launch this up in GDB, we'll go GDB /, and you just need to put the name of the binary we want to run this with. Oops, so this is going to be overflow me. Perfect. And we'll make this a little bit bigger here too. So before we run this, what we'll want to do is put some breakpoints in, or else it's just going to run through the whole thing for us. So to do that, we will go and take a look quickly at the source code, and I'll show you where I've added a few spots to easily do breakpoints. So the first one we'll do is before the function call. We'll also do one at return from function, and then inside of echo print, we'll do before read syscall and before function return. So if you're not familiar in assembly, these are what are called labels. So they don't actually end up usually in the code. This is just for developers for making jumps easier or for just understanding where we are. But since this is assembled and linked with debugging, they'll actually be in the end code that we can look at. So it just makes our lives a lot easier. The other thing you can do is you can just set breaks for line numbers in GDB if you don't have these, but this makes our life a lot easier. So let's go in here and we'll set our breaks. So in GDB, to do a break, it's just B, and then we'll put the name. So we're going to go before function call, and you can use tab to autocomplete in GDB, which is nice. So set break there. Okay, we're going to set another break here. Return. Oops. Perfect. And then what are our echo print ones here? For read syscall. Oops. Okay, perfect. So now we've got our breakpoints set. So what we're going to do now is we'll run this, but we will pass in the input from that AAAA, and then we'll step through and we're going to take a look at a few details for this. So let's go ahead and we'll go R, and we'll go AAAA. You can hit yes if you want to get this debugging info. Perfect. So now we are at line 81, which is all the way down here, right where we're about to call this echo underscore print. So at this point, what I want to take a look at is the return address and the base pointer. So if we actually take a look at the README, it'll give us some details about where those are in here. Perfect. So what we're going to want to check out is the base pointer here. So we'll take a look at where the base pointer is. So that points to where the bottom of the stack is. And then we'll also take a look at the address for this return from function. So to do that, we'll go RBP. So what we're asking for here is I is for info, R is register, and RBP is the base pointer. And then I just want to take note of this. So for us, it's at the 7FFFFD5B0. And then we'll also check a look at the address of where we're going to return from this function. So to do that, we can go info address return underscore from underscore function. And that one is at all fives ending in 1BF. So the way this works is after this call happens, it's then going to need to know where to go to come back into the code. And that is currently at this address. So in a C program, the way that this works to actually tell the function where to come back is that it actually gets pushed onto the stack. The return address will get pushed, right to the stack right before call. It gets done automatically. And then when we return from the function, it will take a look at the return address, pull it off the stack, and then jump to that. And that's how we get back from here. So what we can do now is actually just hit C to continue on with this. So we'll go C here. And now we're right before the read syscall. So what we can do now is actually check and see if we have the layout of the stack and the base pointer. So again, this is something we'll just grab from here in my instructions. And what we can do is actually display the memory itself. So the first thing we'll do is we'll read the 8 bytes above the current base pointer with XXSG $RBP. Perfect. Got any more questions? Is this pre-recorded? No, it's not. I'm doing this live right now. So if you have specific questions about what I'm doing, I am reading the chat. So feel free to drop them in. Okay, so this is what's right above the function stack. So this is the stack from the caller's points of view. And you'll notice this is the base pointer that we saw when we called it. So the reason I want to show this is you'll notice like in main, or up here, sorry, in the function, what's called the function prologue, we actually put the current base pointer to preserve it onto the stack. And then the other thing that's even more interesting to take a look at is if we go here and we go +8. So now we're going even 8 above that. So we can take a look. You'll notice that here we have on the stack all 5s 1BF, which is the address of this. So when we're inside this echo print function, right above the stack for this function, you'll notice we have the return address. So this design in and of itself is what makes stuff that's written in C or C++ or assembly so dangerous for buffer overflows, because of the way that it works to be able to control program flow, is that the return address is always just right above the stack of wherever we are. So if we can overflow the stack, which I mean, there's a lot of protections built in place now, but even in 2025, you'll still see buffer overflows and stack overflows happening. If you can find a way to actually do that, then you can hijack control of the program, because unless we trip one of the defenses or something, when it comes back to this return, it's going to look at what's in this location on the stack and go there. It's just like it's like a core design functionality of computer science and how programs work. So yeah, okay, so let's continue on here. So what we'll do is we will go C. So C in GDB will just tell it to continue until the next breakpoint. So the next one is after the read syscall, before our function returns. So you'll see we split out all these AAAs because it printed it back out to us. So this was the printout from our repeat. However, it didn't crash yet. And the reason for that is we're at before function return. So we're right here before this return. So if we actually just rerun these two commands again, so let's check out the base pointer. So our base pointer is now just all A's. And if we check out here, the return address is mostly all A's as well. So once we hit this return, then it's going to try and jump to this address. So let's actually hit C here. And you'll notice that we crashed with a SIG segmentation fault. So what that generally means when you have a segmentation fault is that your program's trying to access memory that it either doesn't have access to or doesn't exist. And so that's what's happened in this case. It's actually tried to go and return and said, okay, the next instruction I'm going to execute is located at this area of memory. And when it tries to go there, then the operating system says, no, that you either don't have permission or that doesn't exist. And that's what results in a segmentation fault. So at this point now, we potentially have an idea of being able to run an exploit, because what we want to do is if we want to get to hidden prints, so if we actually just do an F here, Control F, and then what was the challenge again? If we take a look at the challenge here, it said something along the lines of printing out, hey, you are not supposed to be here. So what we can do is hop back into VS Code. Let's search for that. Hey, perfect. So we've got this hidden message here. So maybe let's see where hidden message gets called or where it's used. So looks like it's right below it in hidden print. So we have a function here called hidden print, which this is essentially dead code because there should be no way to get here. And it's just in this one as an example. But one thing that could happen is you could use something like this without actually trying to run shellcodes to bypass like something like a login and get it to run some function that you shouldn't have access to. In this one, it's just the hidden print. So if we take a look here before we actually execute this, we can just run this again. So we'll go run, start it again. And if we go info, address, hidden _ print, then this address is here. So it's 5555555129. So if we can instead get the return address that gets put here to be that, then when it gets to this point in the function, it's actually going to jump here and execute that. So let's actually get out of here. So to get out of here, we just hit exit and hit yes. Perfect. And now let's go ahead and modify our exploit. So we'll come in here. And the nice thing with this exploit that I've already written is we've already figured out the amount of padding. So this padding is going to match the size of the buffer, plus we also need to fill up the base pointer. And then after that, it's going to write this. So right now we did all A's, but what we can do here is just put in our return address, and then we will jump to this location. So the one thing to keep in mind is that this is being pushed onto the stack in the opposite direction that it normally would be going on, or that we would normally put it, because we're pushing it from the bottom upwards. So because of that, we actually need to put this in not in the same order. We'll actually put it in backwards. So this one will be 5, 5. This one will be 5, 5. We'll look at this one will be 5, 5. This one will be 5, 5. And then this one will be 5, 1 here, 5, 1. This one will be 2, 9. Perfect. Okay, so let's save this now. And now I'm just going to run this and save this again. So we'll go exploit, Python 3. And I'll just put this into jump to hidden here. Perfect. And now when you're writing these, also just a quick heads up, you want to make sure you don't call this like .text or anything, because we need the raw bytes here. Like you'll notice the formatting of how this Python script works. If you start putting like file descriptors and stuff, you might add like magic numbers and stuff to your file. You want this just to be raw binary, or just raw bytes in byte format. So, because even if you cat this out, for example, you'll notice that it looks now like we've got all these characters that can't be displayed, and that's okay, because it's trying to take the ASCII representation. So let's clear this out of the way now. So now we can go back into GDB. So we'll just go GDB /overflow me. Just make it a little bit bigger here. And we'll run this with jump to hidden. Yes. Oh, I didn't set any breaks. So let's exit this here. Yes. So it works there, but I will show it with GDB. So that worked. So if you just run this, I mean, you get, hey, you're not supposed to be here. So our exploit worked. But I do want to show it with GDB. So now that we know it works, I guess let's just do it again with GDB. So actually we can just set the breaks here. So we'll go break. And really we just need the stuff here. So we'll go before underscore function call return from function. What are the other ones here? Oops. Trying to remember the names of all these here. Return from function and before reads this call, and yeah, that's the important one. For underscore read underscore syscall. Oops. And then, yeah, okay, perfect. So let's run this here. So we'll run this and we'll go jump to hidden. Start this again. Yes. So we break before we're about to call echo underscore print. So let's just do a quick check here. So we'll go X. So X again in GDP is to display the memory. Slash is formatting. So with XG, we're telling it that we want this to be in hex format. And then G says bring back a quad word worth of data. And we'll go $RBP. So this is saying whatever is in whatever the base pointer is printing towards. So right now we've got 7FFFFD650 in our base pointer, but the one that we're more concerned about is this one, +8, which is the return address for main. So what we'll do now, though, is we'll actually just jump in. Actually, what we want to see, sorry, disregard that. We still haven't gotten into the function. What we want to see here is actually the value of the base pointer, which is RBP. And this is 7FFFFD5B0. So let's continue here. So now we're before the read syscall. So this is where we have not overflowed it yet. So this is where we actually want to run these commands here to see. And the one we're mainly focused on is what's above the caller's base pointer. And you'll notice we have 5551BF. And if we go info address return from function, that is 555551BF. So now let's hit C here. And we have overflown now the buffer. And did I not hit a break here? Let's see. Looks like we're missing a break at before function return. So let's go B for function underscore return, because I just want to show how this works. Okay, perfect. So let's run this again. So we'll run jump to hidden. Yes. Yeah, it's easy to get your breakpoints. So we'll just go C here. Okay, so before the recall, so let's just do this again. We'll double check. And if we just double check again, perfect. So right now we're going to be jumping back to the return from function. And then now let's go and run or continue. So we'll hit continue. Perfect. So we've input it and it's written it back to us, but it hasn't gotten to the return yet. So at this point we are right where you code to echo a message. Perfect. So we're right here. So now if we take a look at what's in where the return address is supposed to be, we go here, $RBP +8, and now it contains 555555129. Okay, so we will go and go info address hidden underscore print. And you'll notice that they match. So that's why when we hit C to continue here, now it's going to print out, hey, you're not supposed to be here, because it jumps to there in the function. And then once it's inside of that function, you'll notice we still get a segmentation fault because we didn't actually come into this function properly. So we didn't actually, set up or before the call to actually put a proper return address onto the stack. So when it comes to return here, it's still going to get garbage. So that's why we segmentation fault here. And there are ways, if you don't want to crash a program but still exploit it, to potentially get around that. A little bit more of an advanced topic than we would cover today. However, we did actually solve this challenge. So what I want to quickly show, just because I think this makes it a lot easier to see, is if you actually come take a look in here, there's stack diagrams of what the stack looks like. So this is before we do any exploitation. You'll notice, so this is the stack here inside of the function. So we've got the caller's base pointer and the return address. And then this is that buffer we allocated. So you'll notice we gave it 512 bytes. So after we overflow it, though, we actually overflow all of this, the base pointer, and then we put the return address into it. And then this is where it looks when we return from it to actually jump to that. So that's all I'm going to do on this today. I'll take a few minutes here for Q&A, but I do want to give one challenge too. So if you were following along with this, I didn't do the whole part of level 1 here. So one thing that I will quickly show is if we exit here, quit anyway, yes. Okay, so if you just try and do Python 3 exploits.py and then pipe it directly into /overflowme, you'll notice that you get a seg fault and it doesn't actually work outside of GDB. And the reason for that is some of the protections that are actually put into operating systems to stop stack overflows or memory corruption vulnerabilities. So in this case, it is specifically ASLR, which is address space layout randomization. There are ways to get around that potentially if you can chain multiple vulnerabilities together, which is something I'll do in later levels of this. But if you want to learn more about another one that we would also trip, which is called stack canaries, that is the second part of level 1, where we talk about and learn what stack canaries are and actually how to do a custom implementation of them so we can learn about them. So if you are curious and you had fun with this, then I would suggest, follow along with the second part of this challenge on your own. There's walkthroughs for it and how to actually set up stack canaries and how they work and how we can actually catch someone trying to do this with our own implementation. But that's going to wrap up this challenge. I saw a few people were following along too. So if you got this to go and you got it to exploit and work, then I want to say congratulations. Good job. And if you're going to try it later, definitely let me know on LinkedIn or Twitter or TCM social media. How did you get along with this? And you can rewatch this recording, and there's also a YouTube video about it as well if you want to see. So what I'll do, we're right at 1 here, but I'll take a few more questions before we hop off. I'm sure there was a bunch, and I haven't really fully been reading chat. So let me switch over here to just me in my office here, and I'll take some questions. All right, let's see the pinned ones here. Which area in cybersecurity is the most rewarding to start in and also provides a competitive edge over other applicants? This is a tough one to answer, but the generic answer that I give to people that are looking to break into cybersecurity or to try and pick something is honestly find out what you really like and see how you can get a path to do that. Because if you just go with what's going to make me the most money or the most competitive, honestly, one of the things that's going to make you the most desirable to a recruiter or an employer is if you're really passionate about cybersecurity. It looks like you are doing this stuff outside of work anyway. You're putting in the hours. So I would pick and also say you will have the most rewarding career, maybe not specifically monetarily, but in happiness, which I guess is just my opinion. If you try different things, research about different areas, and land on something that you like, and maybe it's not something that you first will get into. Maybe you're going to have to map out, how do I get into this position? Maybe you have to start with things you're maybe not quite as interested in, but yeah, I would try and figure out what you want to do. If you're just looking for a basic generic one, though, 2 that I suggest are entry-level SOC positions in cybersecurity, or if you can find entry-level GRC stuff, it's usually less competitive, help you get your foot in the door. So I'm currently going through the help desk, and I love the hands-on experience. I just want to say thank you for your comments, and a quick plug for anyone that's interested here. We've got the free help desk course on the Academy. It's a little bit different than what I was showing today. So if you know you don't think that you would benefit from the help desk course because you've already mastered those skills, I would ask as a favor if you know of anyone that might want to try it to let them know about it. It is 100% free, no credit card, nothing, no gimmicks, no catches. It's not a trial. It's always free. The quality of it is the same as our other paid courses. And as this person said, you know, most of it, or I would say more than 50% of it, is actual guided hands-on labs, you know, build out Active Directory, answer tickets, troubleshoot networking. It's all hands-on, not, you know, theoretical, just watching someone read through a PowerPoint or something like that. This is a good one. What is my favorite programming language? For me, it's Golang. That's what I like. Go. I was working as a software developer before this, and I program mostly in Go, so I like that one. I also like C. C will always have like a soft spot for me as well, but Go is probably my go-to question here. All righty, let's see if there's any other good. If anyone has any other questions they want to ask before I hop off, ask them now. I had a quick question. My end goal is to do AWAE, aka Web 300. Where would you recommend I start? I know how things work, but I don't know any programming languages. So we'll, I don't know if you've taken them yet, but we do have two excellent resources on the TCM Security Academy for learning about web pen testing. They're both by Alex Olson, who usually does these streams. There's the practical bug bounty one, which even if you don't want to do bug bounty, it is still an excellent resource for learning about web pen testing, even if you're going to be doing that like enterprise role. And then we also have the professional level one, which is a little bit more advanced. That would be probably the best prerequisite to that. And then there's actually even advanced web hacking that's coming out as a module basis. There isn't a certification for it yet. I always get asked this about like, do I need to understand programming to be a pen tester? And you'll get a lot of different answers on this, but I think if you want to actually be a good pen tester, especially in web, you do need to know some programming. You definitely need to be able to understand code. Do you need to be able to like write a big web app from scratch? No. But do you need to be able to read code and understand how it works? Yes. And like the better programmer you are, the better pen tester you will be, in my opinion. So if you do want to learn programming languages and you don't know any yet, some good resources to start would be our free tier. There's a programming 100 course. It's free. So you could, you know, dip your toes there, get started and see if you like that or not. And then move on from there. There's so many good resources for learning programming nowadays. Like if you just Google around, check out TCM Academy, check out, you know, other free resources. There's so many good resources nowadays for learning it. Okay, I'm gonna do one more question here and then we'll wrap up here. Fire. I am 21 years old with zero knowledge in cybersecurity, but do have some full stack knowledge. Can I switch to cybersecurity? Um, so I wanted to answer this one because this is something that I get a lot of questions about. Can you switch to cybersecurity? And, you know, will other experience be relevant? And the answer to that is yes. I think most people's career path is not like no tech experience or non-tech experience, then cybersecurity. It's probably actually I did IT, I did programming, I did something related to tech, and then move into cybersecurity. And if you're doing full stack, then like AppSec or web pen testing, like you will already know the fundamentals of that. You probably already have a good idea of like what are bad things that you shouldn't do as a developer. So yeah, definitely you could make that switch. And at 21 years old, you're very young. There's people that are a lot older than that are switching. Like I was in my early 30s before I landed my first cybersecurity job. I was doing other technical stuff, engineering and things. So 100%. And I think if you have the attitude that you really want to do it and that you can do it, then you definitely can. So keep that attitude that, if I want to do this, I can do it. I'll make it happen. Map out a roadmap and look into ways that you can best showcase the experience you do in your current job to how that relates to cybersecurity. So one other thing too that I always suggest to people, if you can do this, because there's always the blocker, the catch 22 that you need job experience to get into cybersecurity, but you need a job to get that experience. So if you're doing something like full stack or you're working in that realm, is there any way you can do cybersecurity or do anything job related, cybersecurity related in your current job? So for me, when I was doing development, I was actually at a cybersecurity company doing back end development on like our products, but I wasn't specifically like doing pen tests or anything like that. And we had a program called Security Champions that I volunteered for, that every team was supposed to have at least one, where we were also doing like AppSec role and secure code review. And I volunteered for that. And then that was great experience, already. Then I can say, yeah, at my job in work experience, I'm doing AppSec, I'm doing code review. Even potentially if you volunteer, like, hey, I think we should do some more awareness about cybersecurity issues or phishing. Can I do a lunch and learn about it? Whatever you can do so that you're doing something security related in your current job, because then you can use that as experience. You're not lying on your resume when you said, I implemented this, I'm doing this security thing. Now all of a sudden, you already have some security experience in a paid position, which for some recruiters and hiring managers, that means a lot to them. So definitely something to keep in mind, and great question. So we're a little bit over time, so I'm going to wrap up today. I will just give a quick shout out for a few things. So first one is we do have some live training coming up. We've got a couple. The Active Directory hacking and defending, that one always fills up basically with Heath running it. So if you're interested in that one, check it out. We've also got the SOC one running again with Andrew Prince. The first one was very well received and very popular. So, if you are thinking about going into a blue team role or prepping for the SOC certification at TCM, definitely worth checking out. And then we also have the PNPT live accelerated training coming up, which is a training session designed to get you ready to take the PNPT. And we don't offer that one very often. So there's just a few spots left. Britt, just let me know. It's filling up, like it's going to sell out. So if you're interested, grab it now. We don't do too many spots for it because we want to have enough time to help everyone, not have the classroom be overflown. And I can't remember the last time we did this. It's been a while though, so these don't come around too often. So yeah, if you're interested in those, make sure to check them out. Outside of that, have a good day, everyone. Thank you so much for hopping in. Bye for now.